Hello everybody, ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. That's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So what are we going to be doing tonight? Don't know. Hopefully working on something really interesting though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, everybody. Welcome to this Devember live stream for December 6th. And we're actually a few minutes early on this one. I figured I'd jump right on in. And if we wanted to cover what we did between the end of the last dev stream and now, that would more or less be things like waiting for UPS to deliver a package, which they still haven't. So standard UPS may interrupt rules apply, which is why there are various devices around me that are making little bleepity bloop noises to let me know if someone's trying to get into the complex and at the gate or if they've given up for the day. And also, I checked in some code from last night, and I split that code into quite a few commits. If we watch here, this is the initial commit, which I believe we saw me do, and then I sort of piecemealed out all of the changes that were made. So this one is giving the network thread, the connection lock and the connections that it needs, while thinking at the same time that maybe the appropriate way to do this would be a connection list object, which incidentally is the way I had planned it in my head previously. And then I thought, well, maybe why do I need a connection list to sit between the connection manager and the network thread? It sounds like the connection manager could do that very task. So this is all subject to change, of course. Then I also did a different commit here, which allows sockets to track their state for whether they're connected or not. And an important aspect of that, something that wasn't in the code, but I realized while I was working on it, is in close connection here. I put the connection socket none and is connected false in a finally block just to ensure that this definitely is going to happen no matter what. And that's just sort of at some point, we're going to want to make this smarter here to only catch appropriate exceptions and let the others through. And we always want to make sure that that happens. So I left that part in, but otherwise, there was one other, well, I wouldn't say bug per se, but we'll get to that. In here was where we actually implement the network core, which brings in selecting, fixes our file no method, as we can see in the socket, because it was returning a module level thing. It didn't have the self on it like it was supposed to. And this is all the stuff that we remember from the other day. The thought also occurs that this could be R set and W set, and I assume this call happens and then new lists are returned, so we could just replace them and not have a couple of different values here. But that's neither here nor there. And then we implement the stub reading and writing code. Remember, this isn't proper for how we really want it to work, but it's a good, first hit. Just sending all of the raw data directly. And reading that data in just a block. And when we also tweaked around so that we actually put the encoded data into the queue there. And the last part was this that modified the test code. Now I checked this in last, so all of those other commits, are, if you might consider, untested, quote unquote, if you were to check out individual commits. But I like the clarity of this, especially since there were a myriad of changes here. And one thing that I did change, not necessarily in this code, but I would have to look and see. Maybe we'll go ahead and hop into Sublime, where it has an error and says it's closing a connection. If I run this, this message that's about to pop up right here, where it says, oh, sorry, this one right here, I should say. When it says creating connection and then connection established, this particular text right here, if I was to go into here and, well, I don't think I really needed to necessarily do that way. This here, in our implementation, this self.connected equals true was underneath the log instead of on top of it. This is somewhat important to have it on top instead of on bottom, because otherwise when it says connection established, you don't see the connected tag on the end of this thing, which can throw you for a little bit of a loop. So that's really all I did there, being sort of a busy day, unless you count incessant worrying about how the C# operation for the server is going to go, just on a network related bent. I know it's going to be structurally easier to deal with, but I'm not as conversant with C# as I am with Python, and as you may have noticed, I'm not as conversant with Python as I am with C. I felt more than a little silly listening back at how I had to look at secret code on another monitor and the man page to remember that a connecting socket selects for writability and an accepted socket selects for readability when you're using non-blocking I/O, because that just makes logical sense. If you're connecting, you're wanting to talk out. Of course, you're going to be told when it's safe to write to the thing for the first time. And similarly, if you're accepting an incoming connection, you're expecting to read data more than you're expecting to send something to the other side. So yeah, a non-blocking listen socket selects for readability. Yeah, those are the things. But also, I pondered the network code that we're going to attempt to implement tonight, because the thought occurs that I am very used to working in C with its pointers and its buffer offsets, and using languages like C# and Python sort of still throw my brain for a loop, because I've spent 4 times as many years working in a pointer referencey, non-manual cleanup type environment than I have working with languages like these that garbage collect things for you behind the scenes and guard you from things like null pointer exceptions to some degree and dangling pointers and all of that business. So I think it's important to point out that what we're going to write here will probably work. It's by no means production code, and there are probably way more Pythonic ways to accomplish the same thing of what I'm eventually end up doing here. But this is the first pass. This is the learning phase, and you really got to learn. I personally learn by doing, so I'm going to use the knowledge that I already have, and then I can go back and iterate and clean up, and maybe nothing we write here is anything we want to keep. Still an invaluable experience. So With all of that being said, let's go ahead and jump into actually some network code. But first I'm going to fix my headset because the microphone feels a little in the wrong place. Right as rain. Okay, hopefully that sounds a little better. The meters look like they're perhaps a little nicer. I also took that opportunity while everything was muted to have a sip of late night coffee. It feels like it might be one of those days. So, this file on the right is the top level inside the package code. The one on the left is our built-in one. So, if we remember, the way that protocol is supposed to work is we're supposed to send a 4-byte prefix that says how big the following message is supposed to be, followed by the bytes of that message. And the message is inherently self-describing because the first field that's contained in it is its unique message ID that allows us to route that blob of data once it's fully received into the appropriate protocol message class to be struct decoded. And in a theoretical kind of way, you know, perhaps the length could be part of the message itself instead of being a prefix on the front. Or if we had fixed length messages, that also wouldn't be a problem. That's another way that you usually get around that. You might say an introduction message is always exactly 3 bytes. 3 bytes and no more. And then when you read 1 byte and you know that it's the ID, well, I guess it would be 2 bytes for the message type and then 1 byte for the protocol version, 3 bytes. So once you read 2 bytes and you know what the message type is, you know there's 1 byte remaining. That is the way to go. I want to have variable sized messages, which is why we're doing it this way. So two things have to change. Uh, well, many things have to change, but the two most important ones are this send code. Oh, my goodness, more bleepity bloops. Is that a text message? No, that's someone. Oh, once again, it's YouTube telling me I'm live. Boy, YouTube is really good at that. I'm not sure at what point in the night you should just give up on UPS delivering a package, but it's been riding around in my area on their trucks since Friday, so anything is possible, I suppose. Okay, what was I just saying there a second ago before I got so rudely interrupted by minor phone bloopity bloops? Um, One thing that I did fix, which I just remembered now, is there wasn't a return here, so that if the connection failed, it wouldn't also try to transmit messages. That wasn't a problem for us yesterday, but it could be a problem later on, so I threw that there. I would actually prefer return self close, but until the API is stable, I don't know if close is going to return like a Boolean to tell you if it actually did something or not. Maybe that doesn't matter for here, but nevertheless, um, this is trying to grab some data and then it's just sending it in one shot. So one problem with this is send returns the number of bytes that it actually sent, which isn't necessarily the number of bytes that you asked for it to send. So we need to do some sort of partial on that, and it needs to try to pull more than one message if there is more than one. But since messages are arriving at the connection from another thread, we have to throttle it to make sure that it can't do more than a set number of messages in one loop. Otherwise, it would be possible. With the right circumstances for one thread to just keep dropping messages into the queue, and this thread over here that's responsible for sending them, pulling them out and sending them along, and then it cycles back to look for another one, and there's one there. It's possible to IO starve the entire system if one greedy connection utilizes the network thread for essentially forever. So you have to throw a little throttle in there that says, okay, you've sent enough. It's someone else's turn now. We need to send a prefix byte to say how long the message is as well. And if we're doing that, we also have to track an increment of, or a block, the block that we're sending, we have to keep because we might need to use it for more than one send. And similarly, the receive is going to work the same way, but the receive is more of a but, if you will. So this is one of those things that's kind of tricky, in that right now, the code that's sending, the process that's sending the code is the same as the process that's receiving the code, because we're just transmitting to a local echo server to, oh, what did that do? Whoops, I pushed the wrong button. Excuse me. We're just talking to a local echo server, and as such, once we change how sends work, we need to also change how reads work to be able to verify that it still works. So we sort of have to piecemeal it, if you will, so that we can incrementally test that things are working the way that we expect. So the first aspect of that would be, I think, up here in the init for the connection, we have the manager that created us, the messages that we're sending, the messages that we're receiving, who we're connected to, the socket that we're talking on, and whether or not it's connected. We might have a self dot send data, let's say, which defaults to none. And if we did is writable, if there's a socket, then we're only writable if we're not connected or the send queue size is greater than 1 or. Now this is, if there's a thing about Python that irritates me the most, it's probably this. That you can't have this sort of line without using brackets like so. Now, with that change alone, this is saying that we're writable when we're not connected, because we need to be able to, remember, is writable is going to return true to tell the network thread that we are interested in wanting to write data. And we need to do that when we're not connected, because selecting for writability is going to tell us if we connected or not. We need to do that if there's data messages in the send queue to send still. And we need to now know it if there's some send data from a previous operation that hasn't been fully sent yet. So if you drop one message in and it's really big and we can only send half of it, one pass through the thread, we need to select as writable for the next time through the thread and continue to select as writable until we manage to fully transmit that entire message across, right? So we want to do that. So that should have no effect on anything. And as a matter of fact, well, we'll let that run out, but I'm going to jump to the end and change this to a sleep. Sleep 1 should probably be enough. We're going to get the old bad file descriptor. This happens quite a bit. It's a problem with Sublime. The way that the exec command runs things in the background, I think the threads that are doing reading and writing and displaying things to the output buffer sometimes get a little confused. The process has gone away, but they keep trying to read data from the socket, and then it throws that particular exception. But I think a sleep of 1 is enough for us to know that it worked, and everything will be pretty quick, at least for right now. Later on, we can tweak that up. So our current changes are the connection tracks if there's a block of data that it's sending, and it makes sure that if there is one, it's going to try to write. So here's what we need to do. We need to say, well, the first part is to get the data that we actually want to send, which is, we'll see how we have to order this. So right now, this is always assuming that it's going to pull something out of the queue, right? So it has to say if If self.sendData is none, then self.sendData is equal to this. And we're going to bump those down. And I guess we should probably indent them back. So if we're not connected, then this is what we are going to do, which is determine if we're connected or not and close ourselves and leave if the connection failed. But if the connection worked, we can totally go right into sending messages. And this allows for an API, which we're not using right now, but things could be reworked so that instead of saying connect hostname port, there could be a send hostname port message, and it inherently creates the message, immediately queues it, returns the connection as if it's connecting, and then that message is dispatched right off the bat. Is that something we need? I don't know, but I'm used to writing code that way. So if we get here, then we are connected and we can actually transmit something. So we'd say if there is no data to send, then try to pull one from the queue. And remember that if the queue is empty, in that case, we can return. We can also return here. Hang on a second. That is neither here nor there. Now, again, how could this best be structured? So we're going to try this. If the send data is none, then we're going to try to get one from the queue. That could throw queue empty if there's no messages to send, in which case we can just leave. Now, realistically, in the way this is written right now, that can't generally happen because we selected for writability. There must have been something that we thought we needed to do. Well, it's technically possible that we selected for writability because we were connected. So, okay, good enough. If this doesn't, so if this returns, this isn't going to return none, right? It's going to just throw queue empty. So I would imagine that means if we get to the bottom of the try statement outside of the except, then there was either send data already, in which case it didn't check the queue, or send data was none and it pulled something from the queue and actually got something to send and didn't trigger self queue empty. So when we get to the transmitting thing, we are actually trying to send that many bytes. Now, just a second. I think we also needed one other. When you send a message, it puts protocol message in code. It actually needs to do what this is doing. So I'm going to copy that and paste it here. And we're going to say message equals protocol message instance dot encode to get the message. Then we create a block of size, an empty block, the size of the message plus 4, pack into the block a 4-byte int at the start of the block with the length of the message, and then cram into the block the data from the message like so, and then we would actually put block here. Now, this is one of those things where, like I said, if we were doing this in C, then we would have some sort of allocated buffer. Then we would memcopy the data for the message into the buffer and have a pointer that points into it, or an integer that indexes it as an array that tracks how far into it we've used. And we know that when we get to the point where it's the end, that it's transmitted. That's one way to go if you're using that language anyway. Now here, byte array is an array of bytes. Does it make sense to allocate an array of null bytes the size of the message plus 4, then pack into and do this. From what I've been able to read online, because and this is sort of a problem I have sometimes with, knowing that I'm not supposed to prematurely optimize, but by the same token, I don't want to write obviously stupid code. This needs to pull the data in. So I'm assuming this has to be some sort of memcopy. Memcopies can be optimized. Hopefully this is pretty optimized. The only other way to go would be to have the encode with the blocks thing on the size on the front directly, which it can't do. It would have to put length 4 int with a size of 0 and then pack into the same buffer. So that's something we could do. Inside protocol message instance, but then the encoded messages have their length on the front, so that's where you get into that whole should length be inherently part of the message, and then that's not a problem. These are the sorts of design issues we don't want to screw with. So this is going to say when you put a message into the buffer, the block is automatically prefixed with the size. And remember, that's a big endian size in there. So as of now, we're not going to be able to send anything directly unless we also try to pull data out in the receive. So we don't actually have that. What this and this are is self.send data. Now, just for test purposes, we can hit the build key and it should transmit the message, which should be, instead of 52 bytes, it should be 56 bytes because it should be 4 bytes longer. And then the receive should receive that many, and it should complain about an unknown message or throw an exception or something because the first 4 bytes are going to be this error code or the thing that it's expecting to be the message is going to be the length. It's going to be 56, so that's not going to work. Actually, I guess it wouldn't be 56. It might even be 0. It might accidentally work. We'll see. I can never remember how big endian works. Or alternatively, we could have broken it before we even got a chance. I think I forgot. An operator out. Yeah, I know. There we go. So we transmitted. Oh, that's okay. That's a bug on our end. Okay, so it's stopped now. That's a little something else that we have to do now. We have to say self.send data is none when we know we've sent the whole thing, so that we don't just keep trying to send it again. Okay, so there we go. So now we're seeing that we transmitted 56 instead of 52. We received 56, and there's an exception because unpack requires a buffer of 3 bytes. So that means that, yes, it did indeed interpret the length of this block is 56 as a 4-byte integer. That's 0, 0. The first 2 bytes are the number 0, and the last 2 bytes are the number 56. And it used the first 2, which is actually a protocol message. And then with the remainder of the data, it's not big enough. So it's totally an issue. So we're definitely transmitting the right stuff. So all we got to do now is twiddle this thing. And also, now that we've done this, we can remove this from over here. And I'm going to say, because we have test code on the other file, we're also going to remove this as well. Because the code in here is just going to be the actual networky type code. So we're going to save that. And we can come back to here. Now we need to do the opposite in the receive that we did with the send. So sort of, and we need to track partial receives, but just for verifying that the send is going to do what we want there. And we also need to go back and modify that to send more than one thing, but we're going to have to then try to read more than one thing. So we won't do that part just yet. Data is receive 1024 bytes. Let's make it, I don't know, 4K. Just because, as you know, growing room. Then we're going to say we received that much data. Now, I probably shouldn't have done the thing that I just did. Did that have a decode from in it? No, it had a pack into. Okay. Probably, does this have an unpack from? That part there. So we'll move this file over so we can look at how that's working, because we've received a blob of data. We need to say block length is equal to struct dot unpack from, and when we were transmitting it, what did we use as the code? A big I. So we're going to grab big I there from data with an offset of 0, which is going to be inferred. And then we're going to say message data. In this particular case, because we're just grabbing the data, this isn't how the actual receive code should be working. It should be using that number to know how much more data it needs to get something. But here we're just going to say something that I would imagine. X equals hello. Well, X is, if that's the string for X, then X 4 on is the word hello, because we've consumed 4 bytes. So that should work there. And then we should say log block length is %0 bytes. Format block len, just so that we know that we're getting the data correctly. And then message data. So I think that should allow us to actually receive the message. And there we go. We transmitted 56 bytes. We received 56 bytes. The block length is 52 bytes and error received. So everything is sort of working the way we want for a single send, if you will, with the assumption that we can transmit the block with the block size prefixed on it, and we're able to figure out how to decode it. And if that is the case, we're going to, well, first say stage that and remove the test code from the plugin. And since there is now a dedicated test to get the network code working, the test code. One of the things I'm eagerly awaiting in merge is the ability to press Alt Q to wrap things at the ruler, which is something that I kind of miss from using Git plugins in Sublime, but not as much as I prefer using merge as the actual tool of choice. Since there's not a dedicated test to get the network code working, the test code that is in the plugin proper no longer needs to be there, or at least by the time we want test code there, this won't be valid any longer. And commit it. And this is basically us saying that we're going to track the data that we're trying to send to the other side. Now, I'm thinking for our purposes, we should first work on getting partial transmits to go and partial receives to go. And then once that works, then we can move into adding loops to both of them to try and do as much data as they can. As a matter of fact, for the receive code, it's going to inherently have to be able to do that it's just going to receive a big block of data and then allocate it out to know what it is that it's doing. Um, excuse me, that already needs to be able to be multi-block aware right from the get-go, because it's going to read a big block of data and say, okay, I got 4 bytes. The 4 bytes says I need 26 bytes. I got these 26 bytes. That's the message. I still have 9 bytes left over, so 4 of those bytes are the next message, and away you go. So that part's going to be pre-done, but we're not going to work on adding a while loop to the send until we know that everything seems to work. So we're going to stage that file and say include block length prefix bytes in transmissions. This adds in the missing component in our protocol whereby we transmit exactly how big a block is prior to sending the actual data along. This also implements the send code's ability to track a partial send in that it needs a variable. Actually, that part isn't technically part of what we did there, but we could, if we wanted to, not do that. Then we'd have to pull the code in right to be using the other thing. We'll just say, actually, this also implements the send code's ability to track a partial send. This also partially implements the send code's ability to track a partial send by adding an instance variable that tracks the block that is currently being sent. Now, this is a funny thing. I don't know if I mentioned it in one of these streams before, but I like to put commit messages that describe what's happening and why, because I'm a maintenance programmer. Hopefully that's not too irritating for people that look at my code, but hopefully it makes things more interesting. And incidentally, I've noticed that the subscriber count for the channel has jumped up quite a bit in the last few days. So if you're new here, welcome. And once Devember is over, we're going back to regular live streams and just doing regular package development and monitoring the chat. If you have any questions, you can stop in and ask questions while I'm streaming, or you can drop questions in the comment section below any of my videos, or send me a message on Twitter at ODATNerd if you have something that you'd want me to talk about or discuss. And if I'm capable of doing so, I will, either here or in a video on my other channel. Okay, so now that is a solid base from which to work for there. Now, here's the thing that I'm curious about. Can I specify how many bytes to send? I don't know that I can. Send data to the socket. It must be connected to a remote socket. The optional flags argument has the same meaning as for recv above. Returns the number of bytes sent. Applications are responsible for checking all data has been sent. So that's in some sense unfortunate, because I'd really like to send 1 byte at a time. Send all sends all data to the socket. This is just a side thing that I was looking at previously. Send continues to send data until all the data has been sent or an error occurs, which means none is returned on success. And then on error, an exception is raised. But when that happens, there's no way to determine how much data was successfully sent. In our case, does that actually matter? That we don't know how much was sent? No. If there was an exception that was raised, presumably it would be an exception that's a bad exception, so the connection is probably going to close anyway. But I didn't like that because what if it has to wait an arbitrarily long time? It'll hang the network code. I imagine the only way to do what I want to do is to try to construct a bytes object that just contains one particular byte. So that might be something that we can pull here. So let's go here. We're transmitting that many bytes to the remote end. We can say sent is self socket send self.data, and then if, okay, it's possible for send to actually send no bytes. Again, that might not be something that will happen in this exact case here because this is the start of a new connection sometimes, or if there's only one thing to send. But when we get into having a loop for things to send, eventually it's going to just say enough and stop. So that's going to be the number of bytes that were sent, which could be 0. It could be... Now, I think, what's the logic here? I think we need to do something like this. If we said, okay, that's the data that we wanted to send, and sent was equal to 2 bytes, then we could say x is equal to x sent colon, and now sent is that, so we don't have to track anything. Now, what if sent was none, and we did the same thing? X is still the same number of bytes there. So I guess the question would be, if I said x is equal to, if sent is equal to the length of x, sent was equal to the length of x, and we did that, now x is an empty string. I'm assuming that the same would work for a byte array as well. So we can try to send the data, and this is also something that we should do like so. We're going to try to transmit that many blocks, and we'll go ahead and zoop that like that. Then we're going to try to send bytes over from send data, and self.send data is equal to self.send data sent. And if len self, well, actually, byte array 4. Okay, so there's that. So if I said yes, if x, else no, and actually change this. You notice I use the console as a REPL quite a bit. Okay, so right now that's the case. Now sent, let's say sent is equal to 4. We sent 4 bytes from this buffer. And then we can say x is equal to x sent. Now x is a byte array that's empty, and now it says no. So I should be able to say if not self.send data, self.send data is none. Instead of doing that, so try to send some bytes over. We get a count of how many there are. We update the byte array with the number of bytes that were transmitted, and if that ends up being an empty list, then the data goes away. And we might also throw in a log for short send. Hey, 0 bytes remaining. Oops, that did not do what I expected. And we need to accept blocking IO error and pass it. Am I allowed to do that? Error while sending. Now, this is the stuff that's going to need a little bit more work, so we'll worry about that per se later. We could actually have another log in there to say that it successfully sent all of the data in one shot, but I think if x was equal to hello, what is, that's always the first byte, right? So if sent was equal to 1 and x was equal to x sent, then x1 is now the E. So I think we could, well, maybe space that out because it's looking a little crunky. And this is stuff that doesn't need to always be, we don't need to know that there was a short send until everything is all working. And the idea here for this part as well is if the reason that that send fails is because the thing returns E would block or E in progress or one of those other blocking things, then we don't care. But otherwise, there was an error and we close the connection, whatever that particular error might be. So we could do that. I'm going to copy that and add the :1 like so and comment it out. So we can use that later so that when we send, we always send just the first byte. And then once we get the receive code doing something, we can circle back, toggle the comments on these two lines like so, and do it again. And then we should see it slowly reconstituting the message. But we don't want to do that for right now. And just verify that I still didn't break anything. Goody goody. I guess one thing that we could test here is raise value error. Not really. Just to see what happens. We see transmitting 56 bytes, error while sending. We could actually catch, I suppose, the error message there, couldn't we? That's probably. A little bit of that. Aye. There we go. Error while sending? Not really. Okay, so if there's any sort of error, we'll catch it, we'll close the connection, we'll leave. So that is transmitting. Oh, I broke it. Connection manager shutting down. Received 0 bytes from the remote end. Ooh. That's interesting. Does that happen every time? No, of course not. I think that might be the effects of a dangling connection or something. That's probably something to be worried about in the general case, but for right now. How exactly could that have occurred? Let's not worry about that for the time being, shall we? So we're going to try to, okay, now we also are going to need a couple of things for, well, actually, maybe we check in this code here. Because the way we have implemented this theoretically, well, maybe now let's wait until we actually get the receive code maybe doing something. And if the receive code works, then we can check in the send code and the receive code as separate things if we want. So send data is that self.receive data equals none and self.expected length is none, let's say. So the idea here will be we're going to read data into receive data if there's any left. We always, that's going to be the, we'll see how that works in just a second. That's going to be the data that is read from the other side. And expected length will be none until there are at least 4 bytes in receive data, and then we can unpack them from the start or whatever position of receive data to know that there's another message coming around. And once we get that, then we know that when receive data hits a certain length, then we have a full message and we can pull it out and continue and go on our way. This is by far the trickiest of this whole operation, so I'm going to press the button on my headset control and take a sip of my late night coffee. My late night coffee is powered by a new mocha creamer and also coffee. Okay. Let's go ahead and copy these two down here and see what we can make of this particular bit of action. Now, I'm not particularly happy with the structure of this code, but this part and this part could perhaps be blended together. My policy is make it work. And once it's working, then you can go back and refine and make it better and fix all the niggly problems and things like that. But first, focus on getting something that does something first. So the normal, let's go ahead and paste. Oh, shoot. Wrong key. Oh, I did it again. Dang it. One of these days, I'm going to figure which key I have bound to the git gutter previous that's not doing what I want so that I can jump up there, but it doesn't do anything by default. Okay, whoops, too far. These are the variables that we care about. I'll move them up there. So how would we structure something like this? If we think through it logically, we need to know if there is some data. We'll just do this all inside the try here, and then we can do the same thing as we did up here. Paste it. So if any error happens, we can log it and close the connection, but a blocking I/O error is not considered to be a problem. So the first thing we're going to say is if self dot expected length is none, we need to sort of work on the various parts and then see how we might want to structure. My puppy is visiting us and sleeping under the desk as a mascot for network code. Let's work out all of the things that it has to do, and then we can work out the best logic for applying them. So the first thing is, if the expected length of the block is none, then we need to read at least 4 bytes so we can get a size. There may be some bytes in the buffer from a previous read. So if that's the case, we definitely want to say what this is, right? Well, actually, receive data starts out being none. Maybe x equals byte array, y equals byte array 8, and we need to append from one to the other. Well, I mean, this makes x be 1, 2, 3, 4, 5, 6, 7, 8 bytes long. So that's one way to pull that off. But you don't want to just replace the whole thing, right? Because what if... Well, I guess we, again, do this with strings. If the buffer contained... If x contains hello and a space, and y is equal to the text world, then what sequence of slice gets you... Oh, hey, backwards. That's neat. And if if I did that, oh, that doesn't support that, huh? That's unfortunate because that's totally something that makes sense. Well, okay, then what if x was this and y was this? That doesn't work either, huh? Whoops. Did I not just do this a second ago? I will admit that working with lists and having to use slices is one of the things that has very rarely come up. I guess it's in the send code. Block 4 colon equals message. Oh, so I suppose... Oops. Good gravy. Oh, maybe because that's a... okay. Maybe the issue is that. Sheeps. Probably would have been easier to just do it the other way, wouldn't it? Okay. Now, what if I did that? It totally does not do what one might expect. Let's do that again. What if I said x dot append y? I extend y. That does what we want. Now the real question is receive receive data from the socket. The returned value is a byte object representing the data received. The maximum amount of data can be. I'm going to imagine that means that the data that's returned could be empty. So what if, in that case, in our little read code here, which is this one, we say, just for temporary sake, new data, well, we'll do this. And cut and paste. So that's the new data. And we'll bring this up. And that is new data, like so. Just to change the name to make sure that it throws any errors so we know we've found all of the places. It's a little trick that I used to make sure that I haven't done something too stupid. And when I say trick, I make finger quotes with both of my hands. So we can say that, and then we can say self dot receive data dot extend with new data. So this gets data from the socket and sticks it on here, and now we can go ahead and do something. Now, theoretically, we could maybe say if the received bytes is, the length of the bytes is 0, and again, we already know that if x was equal to a byte array, then yes, if x, else no, prints no. So we could also say if not new data, return. So we want to leave the log so we know that we got a short read. Just for now, these logs don't stay here forever. And then if there isn't any new data, leave. Otherwise, append it. And now we can continue. So if the self.expected length is none, then what do? We can say if the length of self.receive data is greater than or equal to 4, then self.expected length and a comma because we want to fix that whole tuple thing is struct dot it's already down there. Yeah. Struct dot unpack from that and self dot receive data to actually get the length. Otherwise, return. And we could throw a log in there to see. We could say not enough bytes to get block length. So we leave. So if expected length is none, when we get down to here, back even with the if, either we have an expected length or we didn't have enough and we left. So it only gets here when self-expected length is set. So we can say if the length of self.receive data is greater than or equal to self.expected length, then what do? We need to slice just the data from the start of the receive data to the length. If x is equal to hello world and mlen is equal to 5, then x gives us just the appropriate data, and I don't think we need to include the 0 there. It just always works. So if that's the case, then message data is equal to self.receive data colon self.expected expected length to pull that data out. And we also need to redact it from the remainder. Now remember, if x is hello world, thus, then if we put it on the other side, we should get space world to say that we have consumed that data. Self.receive data is equal to self.receive data self.expected length colon. So that takes care of that. And then we can say self, oh, well, we don't need to rewrite it. We can just put it up here like this and scoot it. And we could say log received a message, a complete message. Take that away. We don't need to do that or any of that. So let's review what we've written here. First, because we were told we can receive, try to grab some arbitrary amount of data. The bigger size you put here, the better. There are obvious limits. The underlying socket layer only has socket buffers that are a certain size. On this computer, probably I've echoed the appropriate things into proc to make socket buffers a ridiculously large 16 megabytes or some nonsense, because when you deal with having to receive more than, what is it, at the last test, 8 gigabytes of streaming data coming 50,000 messages a second for the whole of the day, you need your socket buffers to be as big as possible to make sure that things don't go all doolally. So receive the data. If we didn't get any new data, then leave, because the theory is we're working off of a buffer that has all of our data in it, and we need to pluck data messages out once they have been completed. So if we didn't have a complete message last time, not receiving any data isn't going to make it any better now, right? Otherwise, add the new data to the data that we received. Now, this is probably horrible. I don't know how this is implemented behind the scenes. We can only care so much. This is something that could probably be optimized 9 ways from Sunday. Now, if self.expected length is none, now I just realized we have forgotten something important here. If self.expected length is none, we don't know how long the block is yet. So if there's at least 4 bytes of data, then use the first 4 to figure out what the expected length of the block is. Otherwise, leave, because there aren't enough bytes. So after a read, if we have at least 4 bytes, we can get the length and continue. Otherwise, we leave until we receive more bytes. We get, Now, if self-received data is at least as big as the expected length, could be more, then we grab the expected length's worth of data out of there, and we trim it off of the received data and add that message to the queue. We also need to say self.expected length is none, because now we're not expecting a length anymore. And theoretically, this should also loop back as well. And instead of returning, it should perhaps break. But we'll worry about that in a minute. Now that we know the expected length, let's put that up there. Then we do this. So theoretically, this should still work. Error while receiving none type. Oh, I forgot the that was all predicated on the idea that the init call was going to set receive data to a byte array. My bad, because it needs to have something to start with. There we go. Receive 56, okay. Unpack requires a buffer of 3 bytes. Well, I would have guessed we might need more logging in here so we can trace where exactly it's going awry. This is the send code. This is the receive code. So we received some bytes. We extended it. We could do this. Log expected message length is that. Otherwise, not enough bytes. And there we can say received a complete message, else log. Not enough bytes. Have 0, need 1. And what we have is the length of self.receive data. And what we have or need are self.expected length. What do we see now? Received 56 bytes. Expected message length is 52. Error while receiving. Unpack requires a buffer of 3 bytes. By not not print. Not print. Message data is whoop 0040. Oh, did we not? There, we forgot a bit. We need to do this part again. There's the problem. Oops. That's not the thing that I meant to grab, is it? This is the one that I meant to grab. Once you consume the 4 bytes, you should remove them from the buffer. Again, that's not something I'm used to doing because normally that would just be an integer that points into a position in the buffer that we would have already moved past. How about now? We received a complete message. Right on. Now we're going to go ahead and just remove that. And again, let's just double check what we're seeing here. Created a connection, connection established, transmitting 56 bytes to the remote end, received 56 bytes from the remote end. Expected message length is 52, which is what we expect. 52 is the length of the message, 4 is the prefix on the beginning. We received a complete message, error received. There's the message we got. We shut down the thing. We gracefully close our connection. And the run is complete. And we are done. So what if we went up to the send and did this? Now remember, the idea here is this is going to try to send all of the data. This slice makes it only try to send 1 byte, which is the first byte. So sent will be 1. It's going to do a bunch of partial sends. 56 of them, as a matter of fact, before it can constitute the message. So let's see what happens. And there we go. There's quite a few of these, as you might have expected. Transmitting, we tried to transmit 56. There was a short send, only 55 remaining because we sent 1 byte. We received 1 byte from the remote end. There's not enough bytes to get the block length. Then 55, still not enough. 54, still not enough. 52, still not enough. 52, sorry. We have, whoops, I passed it. I went too far. Not enough bytes to get a block length. And there we go. Received 1 byte from the remote end. Expected message length is 52. Now we're moving into the body of the message. We have 0, we need 52. We have 1, we have 2, we have 3, we have 5, we have 15, we have 21, we have 29, we have 36, we have 41, we have 51. We received the last byte, we received a complete message, and away we go. So, at least for this simple test, if sends get interrupted in the middle, it seems to be smart enough to do what we want. So we'll go ahead and do that again. And what we need to do now, I'm going to say, is go ahead and check this stuff in. So let's do that in a way where we make inherently broken code, but not really. We're going to, this chunk here is where it used to just do that is the send. And now is the send, it is doing all this, which incidentally is the same as staging the hunk, but whatever. So we're going to do that. And that is strictly for reception. And actually, we can discard those 2 lines. We no longer need them. So that is all in the receive code. So if we check in our staged files, that's what we got. Now, we probably don't want those logs there, but until we finish the next part, we might have some issues, so we're going to leave that in for just now. And we're actually at an hour of development time, but we're going to go ahead and go quote unquote long on this one by a little bit just to try to get this out the door, because this is really the bulk of what I wanted to do for the client code, short of potential cleanup, our ability to transmit data to somewhere else. And then we can perhaps try to work on the other part unless I find some horrible problem on this in the meantime. So what actually would this be called? We are support partial sends on connection objects. This implements the necessary, and it's always necessary for me to do that because I can never remember which of the 2 things needs to be doubled. This implements the necessary code so that we can handle the situation where a short send, we can handle, short sends. We check how many bytes we actually transmitted to the remote end of the connection. And if it wasn't the entire message, we advance the buffer according to how much we sent so that we can finish on the next round through the network thread. And whoops. We want to also check here. Now again, that's just double check our code. We created an array to store our received data, which starts out initially empty, so we can append to it without it causing problems. That could probably be none, and we can add a check later, but that's a problem for another day, so let's stage those lines. And now instead of 1 read and assuming everything, we read 4K of data, and if we didn't get any data, then leave, which again is, potentially something that's going to happen in a loop. Extend the data that we already have in the buffer with the new data that was received. Fingers crossed that Python is smart enough to reuse buffers internally, but that's sort of outside of our purview right now. If we don't know how long the block is supposed to be, then we figure it out. And there are two things that can happen there. If we have at least 4 bytes, we know that this is 4 bytes long. We could also try to unmagic number that by using struct calc size on this to see, which is probably a good way to go in a more production ready thing. But for right now, we know that's the size. Then we get the length from the buffer and use that amount of buffer and continue on through. Otherwise, we don't have enough bytes yet. We haven't received a complete 4-byte integer. So let's just go away, and the next time through the loop, we will be able to receive more data as soon as it becomes available. Now, we now know we have an expected length. If the length of the received data is at least big enough for the message, then we can use a slice to pull the appropriate data out and discard it from the received data. Set our length to none because we have used up a message now. The next one is going to be starting, so we need this part to trigger again. Then decode the message and put it into the receive queue, say that we did so. And if that's not the case, then we didn't receive enough data, so just loop around. And we also added that error checking. So we'll actually go ahead and stage this entire hunk. And I might actually, oops, do that. Support partial receives. As in the previous commit, this modifies the read code so that it can handle reading not an entire message at once. Data we read is buffered and consumed once we know there's enough of it. First, the 4 bytes that tell us how big the block of data is, and then the 4 bytes, and then the bytes of the actual block itself. And away we go. Now, here's the thing that we just maybe want to finish up here, and that is we might want to say con.send introduction message, and then send an error message. And what will happen if we do that? Introduction message has no attribute error code. Oh yeah, right, because we need to make this part smarter too. The thought occurs that perhaps protocol message could be slightly enhanced so that instances know the message ID as well. We'll see. I assume that's something that's actually in there. Yeah, I don't think that part should actually be up there. It should probably, well, I think we tested that out, didn't we? With protocol version boop dot format message dot protocol version. Whoops. I guess if it's not in the file yet, I can't do that. Okay. So what do we got? We transmitted 7 bytes. We transmitted 56 bytes. We received 63 bytes from the remote end, and we received the introduction message, which is good. But we didn't receive the other one. And why? Because we Now, if I was to check here, I'm pretty sure this returns either none or a message, right? We only called this once, so what we might say is, a little bit of a while loop here. How would make me go about, what's the best way to signal this? I guess some number of we waited at most a 0.1 of a second. That's 10 for 1 second. We might do something like that. And this should be 0.1 at the bottom. Bring that down, bring this up like so. Just to still give it that 1 second time, but it can try to pull more than one message because we don't have any sort of asynchronous notification here. We did see that it was receiving a complete message. So we received an introduction message with protocol version 1. And why did we not pull a second message out of there is the question. Here, let's make this bigger just to give it more time. There we go. There just wasn't enough time there. I may have done the math in my head wrong. What would be the odds? So we transmitted 7 to the remote end, received 7 from the remote end. Then we got an expected message length of 3, received a message. Then we sent that one. So we got a protocol, an introduction with the protocol version 1, and an arbitrary error message occurred. Then we are done. So that's nice, but what we want is for both of those sends to happen as one. That is, we don't want to see transmitting 7 bytes, then received 7 and expected length of 3, and then transmitting 56. We want to see, transmitting 63 bytes because we sent both of them at the same time. And we also want to receive both of those messages at the same time. So if that is the case, and maybe we'll make that smaller like there. Is that still going to give us the time we need? No, huh? Well, as the test goes, it's particularly contrived, but it's still doing the thing. Oh, here we go. And manager shut down, remote build, bloop, bloop, broken pipe error. There was a problem with our code writing too. Now that might be because it tried to write something after Sublime thought it was done writing. I suppose not, or it wouldn't have been caught there, right? Well, again, that's something to look at a later date. It's captured for posterity. So let's say first when we are sending, if we're not connected, do that. Otherwise, do this. And all of this is sending one message, right? So for try and range, let's say 10. Whoops. Oh. Say that. We don't actually care about the index of it. We just want to only do it a certain number of times. transmitting bytes to the remote end. Oh, actually, that part needs to be in there too. Okay, let's fix that first. Let's take that out. So the first thing we can do is this. We can just go ahead and pass. Can you do this? I don't know. We'll worry about that later. If there's an actual error, do that. And we don't need, we do need to maybe return. Well, we'll see what we're doing here. There's only one try, so it's that one. If send data is none, get new data, then try to transmit that data, and then we get to there. So here is where we say for underscore in range 10 at a time, do that. And then we actually don't need to return here, I would guess, because this is the part that's in the loop. So if there isn't any data to send, get some. If there isn't any left to get before the range is done, it's going to throw Q empty and it's not going to do anything. Otherwise, it got some data. It says it's going to transmit it. It tries to write it. It updates it with how many bytes were sent. If we sent it all, we set it to none. Otherwise, it was a short send. And here we can break, because there's no need to go back and try to get more data if there's still data to send and we haven't sent it yet. That's the whole point of using the select, right? If the send fails because the outgoing socket buffer is full, it'll throw a blocking IO error, which comes down to here. And any other error gets caught. And if it manages to send 10 messages without doing anything, it just falls off the bottom. So if we do that, we should see it saying transmitting twice, and then we received the 63 bytes and received a complete message. And of course, we're still having problems with the funkiness of our test. Whoops, did I just insert something I didn't mean to? Yes, I did. I suppose maybe we don't even want to. Yeah, we'll make it longer. Maybe that'll fix something. That's sort of. Oh, no. Okay. No, that is totally expected behavior. We didn't need to do that. We'll leave that there. Why is that happening? Because you can't send multiple things in the send without also having receive, because the send is transmitting all of both messages all at once. Now it did it as two send operations, but the receive end, if we look at the output, received 63 bytes. It got them both, but it's not looping, so there's still data in its receive buffer, but because it's not looping, it hasn't looked to see if there's any more messages there. So until another message comes, it's not going to be getting into the read code to do anything, because this code only triggers when it's readable, right? So that is exactly what we want to do. I don't know that we necessarily want to call receive 10 times. We do want to do that. And then we can say for underscore in range, and again, use the 10 as we did there, and bump those out. So if the expected length is none, let's do that. Now again here, we can break out of the 4 because there isn't enough data left. We definitely need more, and in that case, it's definitely going to arrive from the other end of the socket. Then we receive data, and there's enough of it for the whole message, so we constitute the message, add it, say we received it, And if not, then we again have to break because again, there is not enough data to loop back around and give it another shot at this. So we can break there as well. And then if the receive up there produced a blocking IO error, which I don't know that it necessarily would, then we just ignore it. And if there's any other error that happens, it's a problem. And now we can see that it transmitted 7, it transmitted 56. Together it received 63. Expected message length is 3. It got a complete message. Then it got 52, received a complete message. There's not enough bytes to get block length. And then it received the introduction and it received the error, and away it goes. Now, that could also mean that the reason why that previous test didn't do it one time is because of vagaries of network timing or something. But that is us looping on stuff. And as a matter of fact, if we went in here and removed that and that, and we want to keep all of that business, we don't care about how many bytes we sent. We don't care about the expected message length. We don't care about the log, but we do want to break. We don't care about that log, and we don't care about this log, but we do want to break. And there is the error. Now our output is thus. We received an introduction and an error was received. And note that the connection was established with 2 messages in the queue, and everything gracefully closed and went away. And with that, we are at 1 hour and 20 minutes of our 1-hour stream, but we're pretty good on our network code, at least until we get part of the other end done and try to get them interoperating. So I think that means we're going to start on the scary trying to do something in C# portion of this operation. And it's only the 6th, so actually kind of ahead of schedule, because I sort of figured that it would be about a week to get the network client code going, doing 1 hour a day and talking while I was doing it, and about the same probably getting the server's network code working. And then we got a good 2 weeks to try and interoperate between the two. And I'm guessing that most of the issue that we would have with anything is in the grabbing of data and sending it across, and less so, fingers crossed, getting C# and the .NET code to execute a program and be able to capture its output and send it back to us and all of that good stuff. But we're doing pretty good here, I think. So we're going to go ahead and call the stream. I'm going to finish up my midnight mocha, even though it's only 9:31, but it's 12:30 in the morning on the East Coast, so it's midnight somewhere. I also have a bunch of water that I didn't drink because I had a midnight mocha coffee. And we will generate a devlog and see y'all tomorrow. Of course, I will check in this and push all of the commits up once the stream is done and the devlog is busy wending its way through the tubes of the internet for release tomorrow morning. So until then, you've been someone who's watching the video, and I've been someone who's creating it. And from this end to you, have a sublime day.